We're learning. Awesome. Thank you so much. So the first thing I want to do is thank you all for showing up on this absolutely beautiful night. You all could be hiking and watching the sunset, but instead, you care about data and you are here to learn more and do more with your life and with your career. So thank you so much. I also want to thank Galvanize for allowing us to have this space. They donated the space to us, and they are the only place that we have not outgrown over 6 years. So yay. And I also want to thank our leadership team. So my name is Tony. Hi. We have Greg over here. Jen is not here, but Jen is amazing. She is stepping down, and she is the reason that we are going to be having some new people in. As am I. I am stepping down fairly recently. So next month is going to be my last month as MC, and I'm going to turn into an advisor. I also forgot Patty. Hello, our extrovert, and Dean. Oh, there's no way I'm forgetting Dean. Don't even pretend. All right, I also want to thank all of you guys, like I said, for being here, and I already see some donations into the beer. The beer is what seems to get people to show up. For me, it's always been the data. I don't understand. I'll take the free beer, but it's about the free data and the data information. But thank you guys all for helping us keep the community alive. So tonight, we have 3 amazing speakers. The first one is about I-70 crashes from our very own and very regular Angela Zluka. Yes. And after that, we have Andrew Cassidy talking about Apache airflow. And afterwards, Ari Zalmanow. Is he here? Where's Ari? Yes! Ari is going to be telling us about his previous work as a detective and how data is the new heroin. And then I have a really awesome data ethics icebreaker afterwards, so we can just kill the rest of the beer and talk about this icebreaker. So Analyze Boulder is more than just a show up and hang out and meet people. We actually talk to each other throughout the month. And so the various ways that we do that are through Twitter. So feel free to take pictures, talk on Twitter, talk to any of us tonight, or join our Slack. Because now, thanks to Dean, you don't have to actually email me and wait for an invitation. We have an integration. Imagine that. Awesome. I love that you guys are taking pictures with this slide. We're always looking for speakers. And just a reminder, anybody that has any sort of idea or project or like side thing that's going on, at one point we had a talk about how many miles a gerbil went on this IoT wheel, and it was amazing. So we want to hear from you. So please do apply to speakers.analyzeboulder.com. All right. I gotta admit, this is one of my favorite parts. I want to hear about what the heck is going on in the world. So who's got other events or other hackathons or other projects or other meetups, any collaborations that they're looking for, any other things to announce? Most of y'all missed Go Code Colorado, which meant that you missed my amazing keynote where I said shit and ass way too many times. I'm like, ooh, I just branded myself the shit and ass speaker. But that was it. It was great. Any events? Wow. Summer's going to be quiet. I say summer, it's like spring is just barely starting. All right, well, who has companies that are hiring? Who's looking for people? Damn, now we got the good stuff. All right, Looker and Blue Shirt are going to know who's going first.
Kind of tight. I'm with OS42. We work closely with Looker, but we're an analytics consulting company. Looking as a base point, we hire a lot of people out of CU Boulder massive programs. So they're but strong SQL skills, analytics background, familiarity with Python, R, plus, but really if you have a strong SQL analytics background, Apache Jack and I up front.
Hi, my name's Dan, and I'm with Looker. We're based out of the Bay Area, but we have an office here. We're expanding our office out here. We're hiring engineers. But in my group specifically, we're looking for data engineers. We have 2 slots available right now. So if you're interested, come talk to me, or you can go on our website and apply, but it's not listed in Boulder. It's only listed in Santa Cruz and San Francisco, I think. But they're open to people being here since we're here. So.
Remote work is amazing.
My name is Adrian Cassidy. I work for a New York City-based startup, One Hot Labs. We're looking for a very specific role for somebody who has experience building chatbots. So,
do they have to know everything that you're about to talk about today already?
No.
All right.
Hi, I'm Jay Sports. I'm a consultant, and I've got 2 clients. One client has a facility down in Arvada that does construction, prefab construction, and we need a couple of data engineers. Premium thing these days. And then I also have another startup where we're looking for data scientists in general and data engineers. They're based out of Austin, but I've established a small one. So that is our role. So either one of those, track them down. I'll consider.
Thanks, Jay. So I work at Gloo, so gloo.us, and we are looking for 2 data engineers because apparently data engineers are the absolute new sexy job. But we are also looking for a junior data analyst, which I know is really, really rare. I used to debate over what does it mean to be junior versus senior. We're looking for junior to mid, so come talk to me. I'm happy to put you in touch with the right people and see if it is the right fit. Hi, I'm Lee Alexander. I work at SomaLogic, and we do proteomics, so measuring proteins. We are hiring 3 spots for our applied modeling team. It's aimed at more like a master's level plus a couple years of experience. So junior-ish, if you're looking to kind of get your feet wet and things. Is there laughter? I don't know what that means. We're a really fun team. You get to play with a lot of fun data, and if you're interested, come talk to me. Thanks, Lee. She's got a velociraptor.
Oh, 2. They're fighting and they're riding a bicycle built for 2. So check out their shirt.
More jobs. Right here in the front, right in the middle.
My name is Kenji. It's not me. So we are developing a product actually motion of the organization for fixed. So our product in the market is for the world. So we only have a concept, but we cannot consume it yet. We have to touch this also for the actually our business.
Thank you. Awesome. We have first place, we have captain device, we have all kinds of employees, so everybody's got to enjoy it. So we're looking for any state scientists who can play into it.
Engineers, data scientists, you want to play cool toys. Go talk to them. Any other jobs? There's a guy up here in front, there's this man. Man! Talk to you guys in January and it's silent, but come April and everybody's hiring. This is amazing.
My name's Aman. I'm actually visiting from California. I'm a freelancer. I have a bunch of different clients at any given time, but what I'm looking for is networks of freelancers and consultants, particularly right now, who know how to do data journalism, data storytelling, visualization, that kind of stuff, which seems a little different from already. So if you're interested in that, it's not full-time positions. Come talk to me.
Amazing. You're not going to try to make us move to California, are you?
No.
Awesome. Awesome. Good man.
All right.
Did we try? Did we make you try? No? You're just not hiring? No? Can we like clean your bathroom or something? Last person. All right, I'm actually with Ivanna, which is down in Denver, so if you guys want to commute it. But we are hiring tons and tons of positions for data and tech.
engineers, analysts, all sorts, all levels. So check out our career page.
I also heard you're hiring UX researchers.
We are hiring UX researchers. That's correct.
Okay, any other jobs? Let's call. Let's call. One more looker job.
Sorry, I forgot to mention, we'll also be hiring like sales engineers. We're gonna build out more of those out here in the Boulder, Denver area, so it may not be posted yet, but we're probably open to that.
I love that looker is like the A students in the front row. You guys just like took over right here. It's awesome. All right, so I'm going to introduce our first speaker, Angela Zaluka, talking about crashes on I-70.
Thank you. Yeah, so again, my name is Angela Zaluka. I am with Panasonic. I'm a data scientist there. I work in the V2X program, which V2X stands for Vehicle to Everything. So what we're doing is building a communication system so that your car can talk to poles along the road that are connected by Wi-Fi, other cars, and just X. X means everything. So this is really the future of vehicle transportation going forward, and I'm really excited to be working on it. And this project that I was working on a few months ago is relating weather and crashes and how these things are related. So given the weather data and crash data along the I-70 mountain corridor, we would like to know which factors contribute significantly to crashes. And so about the data that we have so our, the part of I-70 that we're working on is Golden to Vale, and I got pointers. So don't you love it when people like point like with the pointer? Like, I have a pointer, and it works. And so these blue dots, you can see this is Vale, this is copper, like all these blue dots are where all our weather stations are. This is golden, and we've got an extra bonus one up here at I-70 in Colorado Boulder. So our crash data, it goes from the years 2011 to 2015. What these things are is I've broken it down into crashes that were property damage only, crashes that resulted in an injury, crashes that resulted in a fatality. So we've got all this atmosphere and surface and sensor data and crash data, but it's kind of not really any good if a crash happens far away from a weather sensor, like that's not necessarily going to be related in any way. So what I did was take the crashes that could be possibly observed by sensors, or at least the weather during the crash that could be observed by sensors. So 2 miles in either direction or 1 hour preceding the incident, and that's the usable information that I came up with. And so in order to predict our crashes, specifically the crash type, I used the random forest classifier to make predictions. So our weather station data gives us a lot of information. I'm not going to read through this whole list, but just things that you're used to, like air temperature, humidity, precipitation, a lot of things having to do with the time of day and the time of week of the crash. Let's see what else. Wind direction is an important one, and some surface parameters, the visibility, and just a whole host of things that we can get a lot of data from these weather stations. So the question that I found, or answer I suppose that I found was most interesting to in the analysis I did was while the algorithm was able to predict the type of crash, whether it was a property damage crash, property only damage, or fatality or injury, that was interesting. But what I really thought was interesting was what factors in all this weather data led to were the most significant in the prediction. And far and away, the most important thing was the time of day. So So whether it was, it didn't really matter what the weather was. I mean, it did matter what the weather was, but what was most important was the time of day. Kind of evenly across the board, except except like late at night, like that didn't contribute to very many crashes, probably because there weren't that many cars on the road. One other thing that I found that was interesting was that the surface parameters were least important. So like the surface parameters here are the temperature of the road, the friction, what we call the friction number, if it exceeded the road surface, the ice percentage on the road. Those things were least important, possibly because those things were not calculated or measured year round, because they're kind of like winter parameters. Like if CDOT has Colorado Department of Transportation has treated the roads, then it's recorded, but otherwise it's not. So what I did was I took out like anything that had to do with time. So I just wanted to see the weather and the service parameters. And so when we did that, I got to the more weather-related information. The three most important were the 24-hour precipitation leading up to. Sorry, this is a meteorology term that I need to explain. The 24-hour, the precipitation in the preceding 24 hours. That's what I'm trying to say. The dew point, which is related to the humidity and the air temperature. Again, the road treatment procedures for the surface parameters were not always reported, so they were least important. Other precipitation events, like I mentioned the 24-hour precipitation, but there's also the 12 hours leading up to the crash, or the weather measurement, 3 hours, 6 hours, and 1 hour. And those are likely going to be correlated because if it rained or snowed in the 1 hour preceding up to the crash, and it also rained or snowed leading up into the 24 hours leading up to that crash, or leading up to that weather measurement. So I took out everything but the preceding 24 hours and got that now precipitation is the most important. Again, the dew point temperature, which is again related to humidity, which is tied with the air temperature, was the second most important, and then the next most important was the visibility. Secondary importance are wind speed and direction, subsurface temperatures, and the lighting. So like if it was dusk or dawn or fully like daytime or nighttime. Those were all of secondary importance. And again, the surface parameters were least important. So this is my contact information. Check me out on Twitter and email me, and I have business cards if you want to come talk to me, and LinkedIn. My name is really unique, so if you just Google it, you'll find like on the first like 5 pages of Google. So I'm happy to take questions this time.
Lucky duck with a unique name. Like apparently someone named Tony Rosati works at NOAA.
Okay,
Like,
if you find someone whose obituary is in 2001, that's my grandma. That's not me. I'm alive. So
let's go Gary first. Sorry.
Thank you. Was this public data or your company's data?
It was from the Colorado Department of Transportation, so you have to like get an account with them. And
do they also share like traffic density? I imagine that's pretty much accurate.
Same answer. You have to get an account with them to get it. They do have something called Otis, and I forgot what it stands for. I just remember that it's the elevator company name, but it's they do have some data that's out there for use that you can analyze, but a lot of it is kept under lock and key, and you have to have like special permissions to get to it. But Panasonic has a contract with CDOT, so that's how I was able to get to it.
The Vancouver that is a feature, like when roads are packed, vendors in that, and like nobody's on the road and it's icy, you don't have to.
Yeah, that's a good point. I didn't I've been trying to look into that, but it's, again, just being under lock and key, it's been kind of, hard to get to, so.
So were your analyses with data from the whole year?
They were from 2011 to 2015, but yeah, for the whole season, yeah, so it was 4 years. So winter,
that
summer, fall.
That can make those road surface measures seem unimportant when they were really important during the winter.
Yeah, true.
Is there a particular model that you apply to validate the accuracy of your analysis?
What type do you mean, like?
So I'm working on my personal project, and to validate the accuracy of my prediction of what I'm working on, I actually apply the cross-validation.
Oh, yeah. Yeah, cross-validation.
Oh, okay.
Yeah.
Cool. Thank you.
I didn't know if it meant to be more complicated.
Just so I think this kind of evaluation really depending on what kind of conditions you have. Basically, you actually normalize time. But if you then also want to normalize traffic, I think many kind of choices
Yeah.
conditions. Do you have any solutions to find optimal set of conditions for that?
Yeah, it gets even more complicated because there's like, if there's like construction going on, like that can cause crashes. So this was just, for the weather, for now. Yeah, there's so many things that can contribute to that.
Traffic volume.
Yeah, again, I'm really trying to get a hold of that data and I've emailed numerous people about it, but it's hard. They're not giving it to me.
Let's do one more question from Jay.
Yeah, did you examine some other tree models, XG Boost or Cat Boost for your problem?
I did not. But thank you for the suggestion.
Awesome. Thank you, Angela. All right, up next is everything you ever wanted to know about Apache Airflow in 6 minutes. I'm so glad you laughed. Good. Andrew Cassidy.
I'm Andrew Cassidy. I'm a machine learning engineer for a startup based in New York City, so I work remotely here in Boulder. I think I'll start with like the fact that everybody was looking for a data engineer, so like this discussion is like related to that, and that I think I've worked for companies always under 100 people, so I like don't really know what my job title is. I think my boss picked that job title, like this is what you are. But like then the data scientist like doing analysis, and now I feel like my job is to empower data scientists and allow people to play machine learning algorithms and do stuff with data, and that's been the focus of my work. So it's a relatively new thing for me in the last 2 years, and like I've had experience doing it in lots of different ways, sort of like bits and pieces of my job, but the focus is really on like how do we empower data scientists, and the tool that my company has used is Apache Airflow. So what is workflow orchestration? Like really, if you wanted a thesis about what Apache Airflow is, it is workflow orchestration. So like when we want to accomplish some goal, we have a series of computational steps to make that goal happen. And the focus of this talk is really going to be on data engineering steps. Like how do you maybe move data from the operational side of your business to the data platform side of your business, where you can start to do analysis and stuff like that. And the stuff like that is these things here. So how many of y'all out there do one of these things? Dashboarding, reporting, visualization, analysis, serving machine learning. Right, so for my organization, we ship a new model to a production service and a machine learning model to production service every month with updated data given what's going on operationally with our business. And when I came into my organization, it was, our co-founder had a bunch of scripts that The user's like, all right, I'm gonna run this one, then I'm gonna run this one, and then I'm gonna run this one. And this one needs to be run every once in a while, but this one doesn't need to be run every once in a while. Like, none of them are time stamped, and like I give them random names, and then you're supposed to like figure out what the hell to do with all that stuff, or like when stuff's out of date, or when things need to be done. So, you know, despite the fact that I've, you know, studied machine learning, my focus has been on organizing that crap so that we can regularly ship quality machine learning solutions. So I really like this quote. Jeremiah Lowen is one of the big contributors to Apache Airflow. He has since like seemingly making some other product for ETL and data engineering. But I like this phrase, negative engineering is what we do to make sure all positive code actually runs. So like I think of these things, despite the fact that I don't do as much of this anymore, as positive engineering, analyzing data, like finding insight, you know, visualizing something for your customer, etc. But how often do you guys find yourself reading logs, stuff not being there, like you know, things going wrong before you're allowed to do the things that really excite you? I guess I'll ask people to raise your hand. How often do you find yourself doing really cool, sexy machine learning, and how often do you find yourself doing what's called bullshit or something like that? Anybody? Bullshit. Who finds himself doing a lot of bullshit? Okay. Yeah, so negative engineering. So I'm going to go through sort of like when I stepped into my organization, what it looked like. All right, you got to read me with a bunch of steps. All right, run them by hand. Give them specific table names. They incorporate multiple pieces of technology. Figure out what needs to be run, how it's run, etc. Like, what's your next step? Okay, take all those pieces, 1 through 5, put them in a bash script, write it in bash, write something in Python, etc. Put it on a cron job, deliver it monthly. And then, you know, so what is out there in general, like orchestration world? There's lots of different tools. Like previously, I used to do a lot of orchestration with Hadoop using Uzi workflows. And I'm going to skip these other ones, but that was where I came from. And I was like, okay, that's very technologically specific. So what really is Apache Airflow about? And how is it different? And these are sort of the principles, I would say, that define Apache Airflow as a piece of technology. Code as configuration. So you're writing Python code instead of writing bash. You're not stringing things together with Python code. You have an object-oriented sort of framework. You can connect things upstream, downstream. Directed acyclic graphs. Instead of like a sequence of script lines which you need to run, you can connect nodes together. You can have one-to-many relationships. You can have many-to-one relationships. You can have many-to-many relationships where you say, this needs to happen before these things happen. User interface. How often has something gone wrong and you don't know the login to the machine where it ran? You had to figure out how to SSH in the machine. You had to figure out where the logs existed, and you had to read them somewhere. Or you had to read stack traces. Apache Airflow gives a user interface to empower people to see jobs that run regularly, dissect each computational step, click that computational step, and see the logs where failure happened. And then finally, technology agnostic. I bring that sort of back to Uzi workflows where I previously worked, when I previously did. It is not tied to a specific piece of technology. If I have time, I will talk a little bit about each of these, but I'm going to skip these last two for a little bit, because they're particularly important if you want to understand Airflow as a whole. So it's pretty hard to see because it's kind of becoming a monstrosity, but this is my company's workflow that we run every month to ship a machine learning algorithm. It pulls data from a large set of SQL servers, Postgres server, the UI that we power, and does a lot of different transformations from it, and then loads a bunch of artifacts that we then run machine learning algorithms on. The code as configuration thing is, I can see what it looks like, complete gibberish if somebody reads this. Like, yeah, no, code's not gibberish, but like if you're reading this and trying to figure out exactly what it does, we then render it in the user interface so you can see exactly each computational step in this pipeline, as opposed to just expecting people to read code and understand what is upstream and what is downstream from each other. This is the user interface. You're going to see, like, it's not visible here, but you're going to see things like daily, none. You can have monthly, similar scheduling that you get in contacts, but it's actually visualized for you. You can see when your particular run failed, when it was successful, what tasks were successful, etc. So you get a lot of different views of normal workflow items that empower analysis. And then finally, the other part I wanted to talk about was being technology agnostic. And so I'm going back to my extract, transform, load DAG for our company. We have interactions with Postgres, Google Cloud Storage, BigQuery. We have parameterized jQuery notebooks. We have stuff that runs in Dataflow. We sometimes run actual Python code on particular servers, not hitting services at all like that. It's all strung together in this way that you can visualize how we're going to load artifacts for people to do machine learning. Or if you're doing something else, it could be dashboarding, it could be analysis, etc. So that's it. You can find me on LinkedIn, you can email me. And then I didn't really include it in here at all, but I wanted to say, if you are interested in using Apache Airflow, look at Docker Airflow, which is a GitHub repository, and then Google Cloud currently has a product called Cloud Composer, which will sort of stand it up for you and do Airflow for you as a service. So, thank you guys.
All right, so that was super fast. How many people want to buy Andrew a beer? And actually pick his Yeah. Okay, who's got questions for all of us to listen to? Awesome.
Are there any cons that you've seen from using Airflow, or any use cases where you use a different orchestration tool?
I think that one of the things I sort of think about a little bit existentially is like, are workflow tools like JavaScript frameworks, and that they come and they disappear. I would say there's not perfect. There's some features that cause like weird deadlock and sometimes failures that like don't just really take single, like, let me fix the problem, let me click something in the UI and then let me restart my whole like workflow. There's sort of like cons to the tool and particular ways you could use it. I will say, even with the cons, it's better than not having a sort of visual way to look at your workflow sort of as a full organization. So I guess my point is, I think that technology has changed. Like, this is a topic, data engineering is a new like job title. We're kind of figuring it out as we go. And yeah, there is specific points, usually when something fails, about robustly restarting it. And then also, like, there's sort of a style guide for how you need to do things. Like, if one of your nodes has a side effect, you can't just hit clear and rerun it again. It might, like, you know, it might not clean up the junk that it made, and it might fail again. Somebody might be really confused. Like, there's not like, if node fails, how do you clean up? But like, in general, I think it makes my life a lot easier. But there's like, I feel like a lot of concepts that are coming to light for me professionally, but I feel like in general, like, the community is starting to define how we do these things. So yeah, but I think it's getting better in general.
Are you dealing with unstructured data as well as structured data? And if you are dealing with unstructured data, how does your workflow look different than what you showed on your slides?
Well, I hate to ask like an obvious question, but like, we are pulling almost exclusively from operational SQL databases. But then we are doing a massive amount of text formatting. Like, our big tool is a natural language processing tool. So like, our text is completely unstructured, right? And we're formatting that text, we're generating vocabulary and sort of stuff on top of that. I would say that Airflow doesn't really dive into any of those realms. Like, it's not about dealing with structured data or unstructured data. It's just, how do we connect pieces in the puzzle that enable some end goal? How do we alert you to which part failed? How do you see the logs for what part failed, etc. But like, at least for us, yeah, like, I guess if you call free text formatting and like reading text and vocab generation, that's in our ETL, as well as just pulling data from tabular databases and doing transformations from it.
Sorry,
microphone, please. For the people in the back. Yeah.
I have like
Don't make me crack the whip.
Easy. I'm gonna bear. I have like 3 questions. The first one would probably be, have you ran into any issues with, I don't know necessarily the reliability of like the workers with like salary executors, or do you run anything on like with the Kubernetes pod operator type stuff? Or what's your infrastructure look like?
Yeah, so I think this is like a good question, and it's like maybe a deeper question that like in a lot of ways Airflow is set up to be like this distributed thing that like when your operators run, it's picked up by a worker, right? And that worker does that work. In our case, our workers almost always just pick up that work and then call an external service, run this BigQuery job, run this mic, like we're talking to Google Cloud, do this. But yes, we do communicate sometimes with a worker who will then run an entire Python module locally. And yeah, like one of the problems is sometimes, and I've heard of it in particular, none of our workers are distributed. Everything runs on one single machine, which is to contrast how this thing is supposed to work sort of operationally at scale. But yeah, like if that worker fails, as I said before, like particularly with Python, our Python operator, it generates a bunch of resources on disk. And if it does not clean them up and it restarts and retries, it will like either partially read junk stuff from disk or like just fail not in an elegant way because some resources are partially generated on a worker.
That feeds into like probably my second or third question is, you know, like the challenges of working with your engineers, or I don't know who writes your Airflow flows or your DAGs, but writing like idempotent kind of like flows to make sure things like that happen. Is that been a big challenge?
Yeah, it kind of has. I feel like one of the things we've done is we built a lot of check operators into our DAGs, and like specifically check operators are related to any SQL database where like that's how we do unit testing under ETL. Like, is any of this field blank? Like beyond schema stuff, like do we expect, like when we deliver our data, we like count how many things are in training data when we ship our artifacts and stuff like that. But another thing we've done is like if a DAG node is supposed to generate resources at a particular Google Cloud Storage directory or something else like that, it's like we have an assert statement, which is an operator. It's like assert null before, because quite frankly, you can't always write idempotent DAG. If something fails in the middle and it's generating resources or whatever, like you have created side effects. You have done something that is not restart safe. So like if that whole sub DAG or that whole sequence restarts, like assert that the destination is empty. You know, because we've had stuff in production where like we've deduped entire tables, you know what I mean? Because something half ran and then like a downstream like network failure, like lots of things like that. So yeah, we've had to kind of build it into how we construct our DAGs, and a lot of it just looks like assert statements that you would have in like normal code, like assert that this condition is fine before we generate side effects and stuff like that.
I'm going to take the last question just because I can. So on a super high level, since we have so many people asking about data engineer roles, are there certain tools that a data engineer must know, or is it possible to be tool agnostic and still be a great data engineer?
I think, like, I guess I'll go like relatively specific and talk about like how you do extract, transform, load, like how you move from like operations over to like a big data platform or something where you're like not messing with like CRUD apps or like live transactional things. Right?
Okay, you're not allowed to give us another 6 months.
I know. And I would say like you either
I will
like,
maybe do that in the summer.
it's like you either are picking like Hadoop, Spark, MapReduce, like something that is you're programming in a language that does ETL, or you're picking a tool like BigQuery, Hive, and you're writing SQL to do transformations of data and movement of data without all the like special foreign keys and stuff you get from like a normal relational database. So I kind of see like data engineering in two camps. Like you're writing a programming language or you're writing SQL that actually executes at scale.
Thank you so much. All right. Up next is the lead researcher at Twitter's Data Enterprise Solutions. We have already someone on up. I'm going to let you talk about your history because I know you got this down now. Say it first.
Do you think you got it? I think so. You know your history? All right.
All right.
My name is Ari. Obviously, with a title like that, I feel like I'm a meat salesman at the National Vegetarian Association convention. So my name is Ari. I do work at Twitter, but this talk is mine, not theirs. Qualifier. I like to think I'm the world's only consulting detective focused on consumer and market behavior. So I study people at the consumer and market level, and I think that's important as we talk about this, because I am going to posit to you that there is an addiction to big data, and that small data can save the day. If there's one takeaway you take from this, it's that when all you have is a hammer, every problem seems like a nail. Okay, so I guess you're like, well, how is this guy calling him the soul detective or whatever he said before? What I would say is this. I currently have, I'm a doctor. I'm a doctor in cognitive psychology. I studied human learning and behavior. Lifetime before, or this lifetime several years ago, I was a police detective for the St. Louis Metropolitan Police Department. Thanks. I did actually work on both the south side and the north side. For those of you that aren't familiar with that city, it's a gritty place. It's got a lot of violence, nastiness, and other things. So I got exposed to a lot of things in human behavior that most people will never have to be exposed to. One of those was on a call one day. I'm on patrol in the central West End, which is the middle of the city. And I get a call for a disturbance. It's common for many for police officers. They get calls for disturbances all the time. In this particular case, it was just to keep the peace. A young woman, let's call her Sandy today. I never use the same name, and you're not going to get the real one from me. Sandy was getting kicked out of her boyfriend's house. They were separating and going their separate ways. Now, what was interesting about Sandy, blonde hair, blue eyes, I had a chance to talk to her. And as I'm talking to her, she has a master's in business administration, very intelligent, good job, everything going for her. By all accounts, a person that you would bet on, all of you would bet on, to be successful. Well, Sandy was getting kicked out of the house. She was very upset. I asked her where she was going to go. She said she didn't know. And I kept the peace that day. I helped her load up her car so she could leave her now ex-boyfriend's house. And I went on my way. She went on hers until maybe a month or two later, when I ran into Sandy again. I got a call for an overdose in a house. And I walked into the house, and there's many of the houses I went into. It was dirty. There were fast food bags everywhere. Wasn't clean. And I come in the door, and to my left, sitting on a chair, is a guy with a needle sticking in his arm. He's half dead. And the reason police get called for those things is to make sure they're safe for the ambulance. So I tell the ambulance they can come in and help the guy. But what was striking is over on the couch, I see Sandy. She wasn't the blonde-haired, bright-eyed person I saw 2 months ago. Now there was like a darkness to her eyes, and her hair was a little stringy, and she was dirty, and she didn't look me in the eyes. And I noticed the track marks on her arms. And I realized that Sandy had gotten sucked in to the heroin lifestyle after being kicked out of her boyfriend's house and not having anywhere to go. This wasn't his choice necessarily, other than maybe getting hooked on it and being a good guy and doing the opposite as their initial choice. But she didn't choose to be put into this situation. Well, as many of you may know from personal experience, as I do from very personal experience, it was a downhill slide. And I left Sandy that day in the house. I asked her where she was going to go, what she was going to do. She didn't know. I asked her if she wanted help to get off heroin. She didn't want anything to do with that. She was fine. The downhill slide, 2 to 3 months later, I see Sandy sleeping in a doorwell outside, rolled up, barely recognizable, thin, emaciated, stringy hair. I don't even know if she recognized me. And I had her taken to the hospital, which is the endless cycle of addiction that happens with people who are addicted to heroin. They try it, they can't get off it, they don't admit that they're doing it, and it continues and continues. Now, you might be thinking, why are you speaking about something so morose at a place for data? And my argument is that there's a new drug, and the new drug is big data. Okay? So, remember, the takeaway is when all you have is a hammer, every problem seems like a nail. So the new drug is big data. What happens is that many companies, many organizations as they're trying to deal with customer-related problems or looking at innovation for the future, they turn to big data. And there are several problems with this. First is the problem of induction. You've read The Black Swan by Nassim Taleb, I'm sure I'm pronouncing that. He talks about the Thanksgiving turkey. Well, the Thanksgiving turkey lives his life every day with the farmer going out to him, eating him. The turkey's really happy. The turkey comes to believe every day that you, the farmer, is going to come out and feed him. Right up until the day of Thanksgiving, when his worldview is drastically changed. You didn't come to feed him that day. Oh no, he's coming to feed you. So that's the problem of induction. Using big data sets in the past to predict the future behavior, it can be problematic, as you can see, because things can shift that you don't see, much like a turkey. The second is the mechanics dilemma. Mine, I coined it. If you're going to use it, it's trademark. Goes to me. I didn't know that. Okay, more beer, more beer. The mechanics dilemma is that in many cases with statistics and big data, the people who are using that to make decisions have no idea how it works or what it does. All they know is that they took a statistics class in college. They remember somewhere that there's confidence intervals and maybe a margin of error, and then they apply that to everything, forgetting that one of the key components of that is like random sampling. And so what ends up happening is that they go, okay, I'm just going to use this, and then they're using the tool wrong because they don't know what's underneath the hood. Many of you know what's underneath the hood, so it's important for you when you're using this and dealing with your clients, your stakeholders, your customers, that you're explaining the right way to do things rather than letting them go around the wrong way, because they're not the mechanics, you are. Another reason that big data is like heroin is once you get it, you never get enough, and once you get your fix, you start this endless cycle of wanting more. And these companies, what they do is they start consuming data. They start saying, well, we need data, and then maybe we need more data, and then we need data to make decisions, data to justify decisions, data to justify data. And at that point, all they're doing is consuming data and not making any decisions. They're in gridlock. And they become addicted to this because they just need the data, but they have no idea or reason why they need the data in the first place. Obviously, out there, you want to go find somebody to sell you big data solutions, the dealers are in this. I could go on Google right now and find any number of people. And what's really interesting is prior to coming here today, I was like, oh, you know what? I want to see who's misusing statistics in the market research world. I'll tell you what, I tell you, like, 85, 90% of the ones that I found on Google today misusing it some way. The quality is questionable. So big data is only as good as the data set and the location you get it and the people who do it. So on heroin on the street, you're buying it from some unknown dealer. You have no idea where it came from. You have no idea what the quality is. It's not like you're buying it from Pfizer. Here, data is the same way. If somebody's making a data set, you have no idea it's clean. You have no idea what the quality is. You have no idea. Those are problems. And then, again, data, big data, it's a means to an end. It's not an end in and of itself. It's a tool. And it's only as good as the people who are able to explain it and help leverage it. Well, I've highlighted the problem. The solution is data doesn't move big businesses forward. Data is a tool. Action moves businesses forward. So you can give business data. They don't do anything with it. It doesn't really matter. And I'm not suggesting that we ignore big data. I'm suggesting we become smarter about our consumption and our usage of it. Okay, I'm not saying all big data is bad. I'm saying that there's a time and a place, but then there's also a time and a place where big data isn't useful. I am suggesting that there are many, many occasions where we depend on big data sets that we don't have to. We can move forward without it. I'm suggesting that in some cases, we let go of thinking about data and start thinking about the reason that we're using data, which many times is people, customers, the whole purpose for what we do. We all work for companies or organizations that in some way serve people. And then I'm suggesting that we get back to small data, our customers, and build from there. So I would say I am the world's only consulting detective focused on consumer and market behavior. And I use that superpower to help growing dev shops. In this case, it's Twitter, still a growing dev shop, to think like a detective and uncover crucial clues to help them rapidly and profitably build and market products and services that people want to buy. Thank you.
So I asked Ari to actually come on over here and talk about this article that he published, which was what you just heard. So disclaimer right there, I freaking love this guy. But please do rip him a new one. With your awesome ideas and questions. So who's first? Looks like Andrew.
Before you go, remember I was a police officer. Just kidding.
In other words, he knows that I've been drinking.
I didn't drive actually. So I'm going to give you a very esoteric example. So in astronomy, we have one data point, and that's the solar system. How small is too small for data?
So I would say it depends on the scenario and the situation. So getting away from the solar system, because I'm not as well versed in that. In consumer and customer behavior, one data point can be enough. It depends on the level of variance and the magnitude of what you want to understand, the problem and situation as a whole. So an example would be this. Let's say you own a brand new company and you know nothing about your customers. One customer interview already gives you a vast amount of data you didn't know before. So you're already better off than where you were before. Or one data point, you know a ton about your customers, but then you hear a signal. So a good example of this is cell phones, Nokia. 2007, 50-something share of the market. 2010, 5% share of the market. They tanked. And that was off, there were some signals in small data in China that indicated that cell phones were about to make a shift in the market. Now, that wasn't one data point. It's a couple hundred. But when you think about like millions of data points and then 100 is very small. If we would have listened to those data points and explored them further, maybe Nokia's story would have been different.
More questions? Looker from the front of the crowd.
Yeah, so it's kind of a Karl Marx thing where you keep capitalism, but what exactly is small data and how do you go about the process of looking at small data?
So I would say small data is anything that a person can evaluate on their own. And I think that the definitions get fuzzy because the definition of big data is pretty confusing also. And how you go about analyzing small data, I think that's the second part of the question, is really a few ways. One is through observation. One is through analysis of this, thinking through, human thinking through of correlations and causations and connections. Because as we all are aware, just because two things occur next to each other doesn't mean that one causes the other, but a machine might not be able to figure that out. So for example, do an increased sale of ice cream lead to more forest fires? Because both happen. More forest fires, more ice cream. They don't cause each other, they're not related at all. But a big data set might look at that and go, oh, this. And then another problem is that the larger the data set, the more spurious correlations occur. Like you're gonna find things that you might not have otherwise found had you, a human, been looking at a smaller data set. So when we look at sizes, okay, I mean, a small data set could be anything from 1 to, maybe a couple thousand. You don't need a big statistical package to measure it. Beyond that, I would be cautious in giving an exact number because I don't think that the definitions of those are well defined. I think small data is data that is small enough that a person can handle.
One more question.
And I want to shout out because being a cop in St. Louis is not an easy place to be a cop. They used to drop us off downtown when I was little for field trips and tell us if you get past X Street, turn around and run back the other way, otherwise you're going to get shot. It was just normal.
This is a very interesting perspective in terms of data size that you want to draw an insight or conclusion. Now, it is a very common practice that if we analyze from a data science perspective, we always evaluate the bias and variance. Now, if you evaluate the very small data set, how would you ensure that your conclusion is not biased based on that small size?
So that's a good question. And so that's really where human intuition and learning comes into play. Because in a large data set, when you're able to, first of all, there's two parts of that. Let me unpack it first. First is usually in large data sets, there should be some expertise in analyzing that helps you get there. In a small data set, really what it comes down to is proper recruiting, making sure that things are, there's low variance of the phenomena you're trying to study. Looking at the environment, there's some level of human intuition or gut thinking that goes into that play. And we might say, well, that's bullshit, Ari. Humans aren't as good at capturing stuff as like machines. But my counter to that would be, in naturalistic decision making, you have firefighters, police officers, fighter pilots, making split-second decisions that work because of their experience and intuition. And so there's a component of experience and intuition that goes into making those decisions in that. And then I think the second part of that is we need to get away from letting our stakeholders misuse the statistics that are being done. Like I mentioned, like a margin of error. That's my favorite because it's misused all the time. Like they're like, oh, there's a margin of error. Well, random example. You know, well, margin of error is predicated on having a proper distribution. And you don't know that because you sampled purposefully people who obviously chose to opt in and do this. So I think that the second part of that is that we need to make sure that we're using the statistical tools correctly. And then the third part of that is when you're using a small data set and you need that kind of statistical like tool and measurement, you hire a statistician, you hire the mechanic, somebody who understands underneath the hood and can help you figure out with that sample how to do that. Because there are some tricks that can be used in statistics that you're not going to have gotten from an advanced statistics class in grad school, but that somebody who has a master's or a PhD in statistics might be able to do, but more importantly, be able to explain it. So that way you're not like, oh, I'm just going to use this tool, and you're using like a screwdriver to bang in a nail. You're using the right tool to get the job done.
Awesome, thank you. All right, so. On the back to Twitter. Twitter's not up there, just want to point that out. Twitter's actually doing a pretty good job with this whole like data ethics thing.
Right.
Yeah.
There's probably some reasons for that.
There are definitely some reasons for that. But I think it's funny that I'm super into this and then I'm like, oh shit, already ending our night tonight. This is my thought. So thank you all very, very much for being here. We do have a few more beers and we certainly have this room until 8 o'clock. So what I want you to do is talk to each other, debate, argue. Do not punch Ari in the face. He's my friend and he will arrest you.
I didn't forget how to punch back.
Not forget how to punch back. But please do go ahead and meet new people and talk about this. Data ethics is really important to me right now, and so I thought I would close out one of my analyze holders with this particular talk. I would love to hear what you guys have to say. Thank you so much for being here.